Okay, so here's the second try. This time, hopefully the sound is working. Homework from yesterday. Okay, so today we're doing two prop Z tests, two proportion Z test. The interesting thing about this is the null is always the same thing. Remember the null, think of the null as nothing's unusual. P1, proportion for P1 is the same for P2. There's really no difference between the two. So if there's no difference, what would always the hypothesized value be for every difference in proportions problem? Of course, it would be 0 because there's no difference. So if you take the first proportion minus the second proportion, the difference will always be 0. There's two ways to write the null. So for difference for two prop Z test. So P1 minus P2 is 0, or just they're equal to each other. Either way is okay. I don't really have a preference. I kind of like, I guess I like the idea of knowing that the difference is 0, but they're also the same. The alternate only has three directions, right? Either one is bigger than the other one's bigger than the other one, or they're not equal to each other. So, I mean, if you read closely, it's not too bad to get the null and the alternate. This is on a sheet if you were in class. We have this, might be on the back of your other paper there for the two prop Z test. Consumers spend billions of dollars each year in drive-through lanes and fast food restaurants. It's very nice. Like Chick-fil-A does a good job of doing a drive-through window. There's a publication called QSR. They study how well drive-throughs do at getting your order on time and the correct order. In fact, sometimes they have researchers who modify an item on purpose, like getting a burger without pickles or with extra something, and they check and see if they actually got that. They tally that up and so forth. So the question we might be getting to with a question like this is there convincing evidence of a difference in the proportions of accurate orders at Wendy's or McDonald's? So what would the appropriate hypothesis be? Well, the null, we know, and I would call them meaningful names, like P sub M and P sub W. Either one minus the other one is 0, or they're equal to each other. Either one is okay. And it just said, is there convincing evidence of a difference? It didn't say McDonald's is better than Wendy's or vice versa. So I think the alternate would be not equal to. You also could have stated over here. So you could have stated, I probably would have done the more like the one on the right there. Don't forget to define the parameters, right? That's just what we do in the state. We write the null and alternate, and we also define the parameters. The population proportion of drive-through orders at McDonald's, of accurate drive-through at McDonald's, and same thing at Wendy's. Assuming the null is true, common values P. So this is a special formula. This is probably the twist, I guess, with tests. We only use this pooled or combined value with two proportion Z tests. We only use it then. So this is the formula. It's basically, think of this as number of successes on top. So it is on the formula sheet there, but successes, so X1 plus X2, successes for accurate order for McDonald's, successes for accurate orders at Wendy's. You're going to add those two successes up. Instead of doing separate fractions there, we're really making one big fraction called the combined proportion. And then the sample size, same thing in the denominator, we're just adding up the two sample sizes. If you didn't know the successes, I guess you would have to do NP hat for each one to get them. Many times they're going to be given this kind of problem, but it kind of depends on how they ask it. So what are the three conditions for this one? The first one is random. They need to come from two independent random samples. Now you should remember that from two prop Z intervals, right? Same thing, two independent random samples. You have to check it twice for both proportions. Of course, if it is an experiment, it would be random assignment for both. Less than 10%, nothing different about that. I think the difference comes in, if you remember that pooled proportion, that P hat C, it's called, the combined proportion there. x1 plus x2 over n1 plus n2. We use that for large counts. So in the large counts condition here, it's n times p hat combined, n times 1 minus p hat combined, and then you do the same thing for the other proportion as well. So you have to check it essentially 4 times. They're all at least 10. Okay, now they tell us some numbers. Of the 159 drive-through orders at McDonald's, 145 were accurate, and at Wendy's, 139 out of 163. It's hard to tell from that, which maybe McDonald's did a little better, but I don't know. We'll just have to see. Is there convincing evidence of a difference in the proportion for accurate drive-throughs? So we already did the conditions, so we don't have to check them again. Oh, no, we haven't done it for this one, sorry. We did the hypothesis, actually. So random, they should say that in there. A real AP question will say random or random selection or random sample. Sometimes they even say independent random sample. If they say that, for sure, repeat that back. Less than 10%, so 159 is less than 10% of all the drive-through orders at McDonald's. 163 is less than 10% of all the drive-through orders at Wendy's. And then finally, the NP hat. So we've got to, so if you get your calculator out, you can do the P hat combined. So you're going to do, I'm just going to get to that one. So let's do the first one. So McDonald's. So let me choose a calculator page, do a fraction. So the successes were 145. I think at the Wendy's was 139 from memory. And then 159 was the number of sample size, and then 163, I believe. Let's just double check those last two numbers. Yeah, okay. So if we do that, we should get, I'm going to put a decimal so I get a decimal there, 0.882. So we get 0.882, which is p hat combined. We have to do that before we do the last condition, which is the large counts condition. So once you get 0.882, now we plug it in. So n times that. So 159 times 0.882 and 159 times 1 minus 0.882. Same thing for the other one. It's okay to round those to nearest integer. You could probably leave it like that and be okay as well. I think it's either way. We don't need those when we do our calculator portion of the test here, when you're doing our calculator. Suppose the conditions are met. So this is the formula for Z. So this is interesting. If you look at the generic, or you think back to the generic, Z equals the stat minus the parameter in the numerator. Well, the stat is two things. It's the difference in the proportions, right? So it's p hat 1 minus p hat 2. So that's the statistics there. Minus the parameter. Remember we said the parameter, the null, is always 0. So since the null is always 0, we're just subtracting 0 then. Some students leave it off, and that's okay. I think if you have my sheet from class, I wrote that standard deviation formula a little bit differently, or standard error formula technically. I think I put p hat combined times 1 minus p hat combined on top of each fraction, which also works, by the way. And so then you would plug in the numbers for that one. This is just a generic formula. Again, statistic minus parameter over standard error. They do give it, that's the way it looks for standard error. That's the formula they give. So that's why I wanted to show you what that looks like. It's the same formula that I use. It's just conjugated around. I distributed the p hat c and 1 minus p hat c to both terms. Okay, so let's skip that. Okay, so calculate the test statistics. So we're going to plug in to get z. So by the way, they did that wrong. So it should have been, I don't know what they're doing there. So it should have been the, so if you do a fraction, I'm just going to do the fraction there. So it'd be 145 divided by 159 plus, right, minus the other fraction, which is the 139 divided by 163. In the denominator, I'm going to do it my way. So, but they should have had the square root only in the denominator. I don't know why they put it like that. My way is to do it this way. So it'd be p hat, so 0.882, times 1 minus 0.882 all over the first 159 for McDonald's, plus, again, a fraction, p hat, so 0.882. This one makes more sense because to me it's more like we've been doing, but you can do it the other way as well. So that's the way I would do it. Hopefully this works out. 1.646. In fact, I think mine was probably more accurate than theirs just because they rounded a little bit more. The calculator might even be more accurate than that one, actually. But it's close enough, and again, we're going to be okay with that. What's interesting, and let me get something out to do this. Okay, so we've been drawing the normal curve. So that's just 0, 1, 2, 3 to the right, and -1, -2, and -3 to the left. So 1.6 is somewhere in here. So that's a z-score of 1.641. So I'm kind of going there and shading to the right. So you would do norm CDF, and you all know how to do this. Norm CDF, if you don't want to use the calculator to do the whole thing. The lower bound is 1.641. The upper bound is infinity. Of course, the mean and standard deviation are 0 and 1, and that's your norm CDF. You're not going to get the right answer if you do that. It's not going to be big enough because this is something you may not have thought about, but our alternate is that the McDonald's proportion is not equal to the Wendy's proportion. Because that's a not equal to, it's called a two-sided test. So you found the area of this shaded region, but there's an identical shaded region, the same exact size on the other side. In fact, the z-value for that one would be negative 1.641. So what you have to do is you have to multiply the norm CDF times 2. Whatever that number is, you multiply it by 2. And that will give you your answer. So in other words, if you do that 2 times that, you'll get the 2 times 0.05, you'll get 0.1. Some of you might get 0.099. That's the same thing as 0.1, basically, just rounding errors there. Now, we can also do this in our calculator, right? So let's get our calculator out and do the whole test in our calculator. So menu, it's got to be under 6. It's got to be stat test. It's got to be 2 prop z test. You got it. So this is going to be 145 out of 159, and then 139, I think, out of 163. Hopefully I did that right. And not equal to is the default, and we're going to leave it there. And so we get a z-value of 0.099 or 0.1, right? So we did it right. So the calculator does it right. So I highly, highly, highly recommend. I'm aware of the two-sided test, and I forget to double the norm CDF sometimes. It's just, really easy to forget that. So just double checking the calculator, because the calculator get it right, and then you go, oh, mine's half as big because I didn't double it, because you should in that case. We already checked the conditions. So what would the conclusion be? The conclusion would make, same cadence before, there's just one maybe small difference, and that's a good picture, a visual picture of what we did there. Because the p-value of 0.1 or 10% is greater than the alpha of 5%, we fail to reject. There's not convincing evidence of, that's where we differ, a difference in the population, in the proportion. So between the accurate orders at Wendy's and McDonald's. So not just the convincing evidence of a proportion, of the true proportion, but of a difference in the proportion. So that's the difference. We're talking about the difference. I think we did all the calculator stuff there. And yeah, the two things you have to have. So you can just use your calculator. That way you don't have to worry about it. Oh, did I double the z-score or not? Was it two-sided or one-sided? If one-sided, you don't have to double it, but two-sided you do. If you want to read about this and try another practice problem, I would read that and then look at the answer. And then same thing for this one. And then that's the answer for that one, for the conditions. And answer for these three are here. I'm in Lake Tahoe right now, so I'm going a little bit quick, but I wanted to make sure you had some voice for the basic lesson part of this screencast. That's it. Thanks.